Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about ISRO and PSLV failure that is hot topic right now. So what kind of failure we are talking about? We are talking about PSLV C-61, which was 63rd flight of PSLV. You have to understand, most rockets generally do not put mission on the first launch and first and second launches. So PSLV had two test launches, both of them worked. So after that, they got C designation, meaning go. So C-61 means it was 63rd flight of that puppy, and that had issue in third stage unit of it. It's a 4-stage rocket. So third stage had Achu, and it kaputted the whole mission, so to say. And be mindful, PSLV has a lot of variants, meaning based on the tonnage and the payload capacity needed, we can strap a lot of booster to it, or have few booster to it, or have no booster to it. So this is 27th flight of XL variant. If you see a lot of boosters, that's the reason for that. Lot of stuff. So it needed some extra oomph. And yeah, it went kaput. And then we had PSLV C-62. This was 64th flight of PSLV. And again, the same issue. The third stage went kaboom. And that again caused failure. This time, ISRO actually was unable to stop the broadcast. They actually showed what the hell was happening. So yeah, flat out, that mission failed. Be mindful, this time it was a different variant. This was a DL variant. It was 5th try of a DL variant. And yeah, that also went to boom, which is weird given the fact that a PSLV series of rocket is very reliable. It's what we call backbone of Indian Space Agency, ISRO. Basically, it's the workhorse. We launch this puppy every other day. It's almost like our Falcon 9. So one boom, things happen. Two boom, exact same way, one after the another. Yeah, that's bad. And be mindful, the C-61 happened on 16 May 2025 and the C-62 happened on 8 January 2026. That's an 8-month gap. And again, once the first one went boom, we did have what we call a failure analysis committee, meaning again, whenever this sort of things happen, they generally establish a committee who's supposed to go through everything in detail and figure out what the hell went wrong. And yeah, they did that. Apparently they did not do a very good job, and same accident happened again. Now let that be very clear, as of now when I'm making this video, it has never happened in the history of a space program in recent, as in 90s point of view, where rocket that has been working, it's a rocket, it's a working, again, we are talking about 60th launch. It's a normal done deal. We do not cover PSLV launches because it's a done deal. It's bro, done, go home. It's like covering Falcon 9 now. Nothing will happen interesting into that. It's yeah, it's done, it's sorted. Now imagine one Falcon 9 going boom. Has happened. That's not a new thing. But has one Falcon 9 went to boom, and the second Falcon 9 that was second in launch sequentially went to boom? That never happens. Space shuttle went to boom 2 times. Again, gap. You will never have a scenario where rocket goes boom one after the another and with exact same way, because that means the FAC messed up their part. Because again, if something else went to boom, that would have been okay. But this was a very rare event. Yes, Falcon 1, SpaceX, when they were new, they boomed 3 times their rocket. That's normal. When you have a brand new rocket that is coming for certification, it is expected that it's going to go kaboom. For example, even Ariane rocket from ESA went to boom. It went boom 2 times and they did not like it, so they redesigned the whole thing. So it's normal to have boom events when you are developing the system. Impossible when the rocket is a done deal. So that's a very, odd thing. So 64th flight, 63rd flight. Yeah, this was bad. So what are the cause of it? Well, cause is ISRO did do a failure analysis committee, but they have classified the result. They have not shared it, which does have a consequence. We'll talk about that. But what we know right now is this puppy sneezed. So this is the third stage and it's causing issue. It's a solid booster that is made out of HTPB, hypodroly terminated polybutadiene. Who the hell come up with a name in chemistry, man? basically HTPB. And this is a solid stage booster. Now again, it's not a big deal. It's just supposed to do final trimming. So it's 7.6 ton and it has flex bearing sealing gimbaling nozzle. So this nozzle goes. Now be mindful, flex bearing nozzles are not designed to go dinch. It's a very limited range of mobility. So you are talking about 2 degree plus and minus, meaning the total range is 4 degree. To give you a context, if you compare it to SLS, that could be as SLS solid booster, that could be as a wiggle room could be 4 degree plus and minus. That's 8 degree of movement. That's a lot of wiggle room. So this rocket, if it detects any sort of asymmetry, it does not have enough wiggle room to like compensate. They are assuming the PSLV is designed in that way. Booster does the most of the heavy lifting. Second one just finalize everything. Third one is just like, just that extra kick. Fourth one is just like, okay, trim the exact orbit. And yes, it can be launched with 3 only. They generally use 4th. So that's the whole point. And to make sure the weight is light, they use filament wound composite case. So it's a done deal. Be mindful. It's a very shocking thing to talk about something that has worked 60 times, give or take, and like now it's going kaboom. So it's a big deal. This is the flex nozzle system. So they have a flex seal inside the casing. That's a very complex challenge, but apparently it's a solved deal. So with a very small actuator, they have some wiggle room. And this was the animation they shared. Be mindful, there was a scene where in the live broadcast you can see somebody was monitoring the camera of the 3rd stage and it showed like the wrong orientation. So we know like it went kaput. So we know this is the issue. What exactly in it, we do not know. There could be a scenario where the nozzle seal could be kaput. There could be a scenario you could have a burn through. So just now, this is not in my Hindi video, just now I learned about it. Somebody say because we might have changed the microprocessor on the 3rd stage, it might be the bad firmware. That would be really bad. That would be really, really bad if we kaputted a reliable rocket because we did not handle the firmware. That would be like, eeh. So that's the cause. Again, 3rd stage is the cause. We just do not know what in the 3rd stage went kaput. So what is the casualty of this sort of boom events? Well, insurance premium goes up. Even though ISRO is a known company, known brand, known reputation, if your rocket keeps going boom, the premium goes way high. It's almost like stock market, premium goes high. And again, if you had one bad event, premium goes a little bit high. If you have 2 consequently, it's almost like company might not even insure it because you have to understand there is a sweet spot of insurance. They cannot charge you the same price as the basically craft. Let's say satellite is $5 million. They cannot charge you $5 million. You'll say like, hey bro, it would be cheaper for us to make a second satellite. Second satellite is always cheaper. Like for example, if it takes $10 billion to make the first James Webb Space Telescope, if they control C, control V it, at best they would require $1 billion more to make the second one. It always happens. It's a normal thing. And back in the old day when rockets were very unreliable, especially with geostationary, they are always used to make 2 of them. They were always assuming the rocket could go boom, and if it did not go boom, cool, you will have 2 satellites to do extra coverage. So again, you can understand they cannot charge 100% of it, so they have to charge a little. And if they, again, because second one is always cheaper, they have a limited spot. So if a rocket is very new, the company might not even like, let's just say a brand new company is coming into market and like, hey, I want to insurance. It's like, no, you don't. Just make 2 of them. Like flat out, company will tell you, it's like, it's not economical, just make 2 of them. So insurance premium going up is an issue. And again, that's why if they understood what exactly went wrong, if the information was public, it may have softened the blow. But if they do not understand it, they're like, bro, it's a high risk mission. So that is there. That's a big issue. Another aspect is startup does not get 100% money back. Insurance is not 100% of the money you get back. It's almost like cars insurance. Like on paper, it's like, oh, you're going to get this. It's like, no. Your resale value of the vehicle would be returned to you. It's like, bro, what the hell? So it's similar to that. Like the lawyers on top of lawyers with some extra lawyers to fry your brain. So startup does not get the 100% money back, even if they had good insurance. So that is there. And assume they got it. Problem is time. Time is the more painful aspect. And this is where ISRO really starts to crack. For example, let's just say one boom event happened. Cool. When is the second slot? If it's 1 month from now, it's like, okay, people can huddle together for, they can maybe be able to let go of their salary for 1 month. But if like, okay, another launch is 8 months from now, yeah. It's like you are talking about payroll for 1 extra year, and startups do not have that kind of runway. So, and again, it's not expected. If you are like a new company is coming in and then you are risking your satellite there, that's on you. But if you're like, it's a ISRO, it's done, bro. It's a known rocket. It's a workhorse rocket. It's done. We do not even cover it. It's done, bro. It's boring. And that goes boom. That's like, who do you blame at this point in time? So that's a very, what you call, painful thing. For example, there was this company, SpaceHab. They put their payload into a space shuttle, and that space shuttle went kaboom. They did not have enough money, did not have enough runway to wait for second space shuttle launch to come back, and they got acquired. And it happens. Like, this is a very common story in space industry. So it's a normal thing, does happen. And countries, while ISRO does have a good relationship with other countries, they will also now start to look with other options, because again, they have a lot of wiggle room. So you have like Indian startup, they can only deal with India. While international clients, they're like, bro, we have portfolio at this point in time. We don't even have like option, we have portfolio, and each portfolio has catalog. So Brazil, where was Brazil? Yeah, Alto Space from Brazil, they had their stuff, re-entry capsule, that went kaput. UK had SSTL, so that went kaput. Nepal had their Antariksha Parishthan, that also went kaput. France had their one. Where is France? Yeah, France has a ride payload. Yeah, that also went kaput. So that is a very inconvenient truth, where they're like, bro, we can go to other countries. Like, SpaceX is just there, man. And you are like, okay, these are too small for SpaceX. Yes and no. Yes, it is small, but SpaceX does ride sharing to solve that issue. So it's no longer clean slate. Oh, and be mindful, there is a Rocket Lab also. So that is there. So that's there. Another aspect is time between next launches. Now I'm pretty damn sure they're gonna wait more than 8 months, because now they have to make sure it's okay. It happens that rocket goes boom. It's again, I have failed to found same mistake happening second time. And even in Falcon 1, when one went boom, okay, we had this issue. Another went boom, we had different issue. You're supposed to have different issue. You're not supposed to have the exact same issue. So that simply means they kind of messed up, and I'm pretty sure they're going to do very deep dive quality control on the next one. So expect almost a year before the next launch. So that's a very bad blow to the trustworthy and reliability. And again, that will fall back to insurance. And again, people might be like, would it be better to just make 2 of it and send it to 2 different SpaceX launches? So you see the paradox. So what exactly is the problem when we are dealing with this sort of thing? Well, PSLV was built on old philosophy. For example, if you look into rocket, and I'm talking from V2 rocket, you'll find there was a different jumps, like how our mobile phone went from analog radio to like actual digital radio to 2G to 3G to 4G to 5G. These are philosophies, like, okay, this is how we're going to deal with it. The law of physics did not change. We just, how we are doing things changed. So like it was a big deal that in 3G, it was like, data is separate, voice is separate. But in 4G, it's like, bro, it's all of it is just data. How do you encode it? That's different, but it's all of them is data. Cool. So rocket also had the same thing, meaning if you looked into V2 rocket, all the fuels were diluted with water. The reason was that if they did not do that, if they burned it like full fuel at full 100% oxygen, regenerative cooling was not done. It was not sorted yet. That technology was not sorted. They had some regenerative, it was not good. The metal alloy was not that great. The flow rate was not that great, and metallurgy used was not that great. So if they had tried to do 100% fuel with 100% liquid oxygen, yeah, they would have kaputted the engine. It took a lot of time, like surprisingly a lot of time to develop an engine that's like full of fuel going YOLO. So, and again, same thing happened with a turbo pump. First we started like, letting the exhaust go, then like closed loop cycle took time. So there are steps from rocket technology where you can see, okay, we had this is sorted, we had this is sorted, we keep going up. If you want to compare what is the PSLV era, like, okay, which year it makes sense, it is in 1980s. The rocket is made out of the philosophy where it's like, okay, let's make a small rocket. It's not that it's a good idea, is that we can't afford or trust anything bigger. So let's make a big solid booster or a cryogenic system. Generally, we do not even use cryogenic, we use hypergolic. Again, back in those days, it made sense. If you see like, Chinese rockets, many of them very toxic fume, that's the whole point. So use hypergolic, because that's like, trustworthy, like it will ignite. If they touch, it will ignite, you do not have to worry about it. So that sort of philosophy is there. 4 stages for a tiny rocket that barely puts 3 to 4 tons to orbit. Too much. Yeah, scientifically, mathematically, it makes sense that look, more stages you have, the more efficient it becomes. It's just that at some point it starts to backfire. 4 is that backfire point. And again, let that be clear, not from a rocket point of view. From point of manufacturing, it is bad. And again, you also have many configuration. If it was just 4-stage, like 4-stage done, go home, okay. It's like 4-stage, then you have like 5 or 6 portfolio options. Yeah, that's bad. That's just bad. Simply means your current design that PSLV has, like how many quality controls they have to do, check, quality control check, too many. Like I'm damn sure if you actually do part by part, like how many parts are there? Again, part complexity I'm not talking about, like part, this is a part. There is a very good chance basically Rocket Lab has less part. There is a very good chance basically Blue Origin has less part. Because again, just so many stages, every stage has their stuff. So it's like, yeah, it piles up, the cost piles up, the mess piles up. So, and let me this rocket, while it is good in ISRO's context, it's not going to compete in open market. Yeah, 1980 technology was good in 1980. And again, that was the sweet spot for ISRO's maximum performance. NASA was becoming too bloated. ESA was becoming too slow and bloated. So there was a sweet spot. And Russian systems, while they were good, it was just too much messy and like, so ISRO had a very sweet spot of wiggle room where people wanted something low cost, but not overpowered rocketers like, ULA offering or Roscosmos offering. So there was a blank spot where we could have occupied. We did, and ISRO milked that puppy like there is no tomorrow. But yeah, that era has changed. Now we have private players, and each single private player can shift delete whole ISRO's portfolio. That is not acceptable, so to say. So flat out, if it was competing in open market, yeah, this rocket would be out. It's like, bro, you are launching what? Yeah, no insurance for you. Yeah, we will not even bother with it. It's like, no. I mean, like, if you want to see how frustrating it is, look into the launch tower. You will understand what do I mean by parts count. The more stages, the more part, the more wiring. It has more wires than Falcon 9, and Falcon 9 is exponentially more capable. I'm not even talking about human rated one. Again, PSLV is not human rated. So I'm talking like Falcon 9 that is not human rated and PSLV that is not human rated. Falcon 9 launch tower, erector tower is simpler than what PSLV has. So it's like, it's not cost effective. And low cadence. If it was this, like let's say you made it, but if it was like, we are launching one every month, it would be fine. It would be just fine. That's how China is, enduring it. It's just like, yeah, it's just fine. But we are brute forcing. They're launching almost 60 launches a year, or maybe even more than that. So not having cadence also, that makes it painful. That just makes it like everything is like, what's the point of you doing? Again, there was a sweet spot. That spot has gone long ago. We are in 2026. That era has gone long ago. So that's the thing. Meaning they have to retire this puppy and they have to replace it with modern system. While we do have modern system under next generation launch vehicle, I'm not sure when it's going to be ready. So, and again, this is the best line I've seen in any rocket company. This is from Blue Origin. Single configuration for maximum flexibility and savings. You know why they have that? So they can bitch slap ULA's new Vulcan rocket. It's like, oh, we have these options and we're going to strap on. No, you do not want that. You want one rocket so it can be mass produced. You want one rocket so it can be quality control. You want one rocket so everything is simplified. 2 stages, go home. No solid booster, no BS. Rocket, go. Again, Falcon 9, rocket, go. They have Falcon Heavy. How many times they launch it? It's just once in a while. And again, because they amplified everything in one rocket, they have 3 launch configuration on one rocket. First, kaput the whole rocket. You get the maximum tonnage. Kaput the land back to return to land. Okay, land it on a barge. You get medium payload capacity. Low capacity, if you are launching something very lightweight, bring it back to the land. So 3 configuration just on one goddamn rocket. So you see, single configuration, maximum flexibility and easy mass producibility. So there is a problem, like we have to change this. This is cool and all for 1970s. It's just that we have crossed that threshold, man. So what can we expect in the future? Well, many times people in India, again, I do understand that, and I used to be one of that, where it's like, we were comparing this to Pakistan. And again, if you're like, why India is so focused on Pakistan? We both got independence at the same time, and we used to be one country. So it's like, it's a personal rivalry. So we compare to Pakistan, it's like, bro, we are flying. Like, you don't have a space program. We have a space program that I'm comparing to NASA. That's like, bro, you can compete. You just like, you have to let your wings out. It's not about money anymore. It's just let your wings out. So government organization always has this issue. It does not matter whether it's NASA. If you want to understand about NASA, look into Inspector General Office from NASA, and then you will understand. If you want to understand about ESA, same thing, Inspector General Office, and you will figure it out. Like all government agency has this 2 core factors. That's why they never perform. They do not have consequences, meaning ISRO got a lot of money, like a good chunk of money to upgrade their administration software from one package to another package. Like, you know, hey, that was cool for 1980s, let's upgrade it. They got serious money. What happened to the money? Gone. Again, this is not me saying it, this is our inspector office in 2018 report. It's like, what the hell is happening with our navigation system? It's years behind. So it's like, what the hell is happening? And then they figured it out. Yeah, we gave money to sort this issue, lol. We gave money for this, lol. So all the money was just like gone, and here's the deal. There's no consequences, meaning this thing happened. That's an absolute fact, it happened. Who you gonna fire? No one. Who you gonna kick out? No one. Who you gonna jail? No one. Like SLS supposed to be like what, $500 million per launch. Now it's more than 2 billion. Who's you gonna roast? No one. Who you gonna fire? No one. Who you gonna jail for embezzlement? No one. So there is no consequences. And because it's a government system, there is no competition. Who else you gonna go to? Like everybody, I'm like, this was the best line. This is in an interview. You can find it. It's like, you know, why you are building Ariane 6? We have to swallow it. It's a tough pill to swallow. We have to swallow it because we don't have any alternative. If we cancel this project, there is no other project that is ready to replace it. And Ariane 5 is like reaching its, like, you know, end of life, so to say. So it's like, it's a hilarious thing. It's like, there is no competition. Who else you gonna use? And there is no consequence if they don't perform, lol. So they chill. So you have to understand, like even NASA, like the best of NASA is Apollo era. After that, it was like, now SLS is like, bro, this SLS will be the last rocket. Like you shall not touch rockets. Ask for rocket, but never build a rocket. That has happened. So let that be very clear. So what does it mean for Indian? Well, for Indian, it means we have to foster cost competitive private companies. It has to be cost competitive. It cannot be like, okay, you just have to be cheaper than ISRO. It's like, it's not going to last very long. And be mindful, we have a good relationship with a lot of international partners. It's wise to maintain it. So it has to be cost competitive, not just like, okay, if you're an Indian startup, it is cheaper for you because again, shipping cost. So it cannot be like that. It has to be cheaper. And again, it does not need to be exactly match one-on-one. That I don't even think is viable, but close enough. Close enough has to be done. Failure to do so is like, lol. So what does it mean for government? Well, government should focus on flagship mission, mostly human-rated mission. You have the money, time, and go YOLO on it. Okay, fine. But anything else is like, don't even bother. So basically deal with bureaucracy, paper, and all that, and not 1970s technology. So that's the thing. And to give you a context, Rocket Lab's Neutron, if it comes online, and if it works, and by the end of 2026, this single rocket will have more launch capacity in tonnage than everything in ISRO's arsenal. The whole ISRO arsenal, one rocket company, small startup company. So yeah, that is there. And to give you a context, our big rocket, which is our GSLV Mark III, which is gonna be upgraded to human-rated one, that is barely launched 2 times a year. That's maximum launch cadence we did. Blue Origin did that in their first year of launch. First time they launched, they did 2 launches in a year. And they are pretty sure they are trying to do 6 or 7 launches next year, as in 2026, this exact year. And let that be very clear, if they actually launch the 3rd mission by February and they landed on a moon in February or even March, shut up, take money. Like, oh, by the way, that's an ultra heavy lift class rocket. He's like, we are not even in the same ballpark. Like Neutron, same ballpark, like the same number of zeros. That's on a different level. So that's Blue Origin. And what about SpaceX? Yeah, SpaceX does 160 launch in a year. Whole ISRO's portfolio is 104 launch. We are not in the same ballpark anymore. At least China can say like, hey, as SpaceX cannot say like, you know, the whole China's portfolio in 1 year. So yeah, you can see the point. Like, it's cool and all. It was great. There was a sweet spot. We were milking money. We were the, like, you know, champion, cost-effective champion. But that era has passed long ago. And if we do not upgrade, we do not improve, yeah, we can, like, you know, keep shining this PSLV. It's just not going to last very long. So let's see what happens. So this was my presentation on basically what the hell is going on with ISRO and PSLV boom events. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.